Good afternoon. Let me start with something we all have either seen or heard of a tragic car accident. Uh, Many of the accidents happen while overtaking, especially on highways, during poor visibility conditions like fog or heavy rain. Even with today most advanced sensors and cameras and vehicles still struggles with one major limitations, which is they don't talk to each other. Uh, uh, that is where vehicle to vehicle communication or V2V comes in. And that's the focus of our research. My aim to explore how intelligent network between vehicle can not only reduce pollution, but do so in a scalable privacy preservation and cost effective manner. Um, and before analyzing the topics, mm, let me introduce myself. My name is Vasant Kumar from BTech and Robotics student from Shastra University. I'm here to present my end semester assessment on vehicle-to-vehicle communication and federated mesh learning. This work was guided by D.N.R. Rajan, associate professor in the School of Electrical and Electronic Engineering, and my problem statement is why V2V? Uh, See, 60% of the accidents are due to blind spots or obstructed views. In each year, 1.3 million people die in a traffic-related accident. 79 of these fatalities are preventable with V2V communication. Traditional infrastructure-based V2V systems relies on roadside units, which can cost between $20,000 to $50,000 each. Centralized system introduce privacy concerns, exposing GPS coordinates and driver behavior data. Our research, uh, our research addresses these challenges by proposing a federated mesh-based V2V model. But before getting to our solution, let's explore what the current literature says. I have been analyzed six recent and prominent research papers in this space. Let me walk you through the each paper and the contribution and limitation. And the first paper is uh, vehicle to vehicle communication by Alan et al. This objective of this paper is exploring the scope of V2V communication. It emphasizes its importance and various challenges and outlines a potential future research direction. The methodology they have proposed is the detailed literature review and technical analysis focusing on dedicated short-range communication, which is DSRC, one of the primary technologies of V2V. The hardware and software they are used in this paper is they examined simulation tools and DSRS modules. They are essential for testing V2V systems under various conditions. Uh, in the sensor, they have used this interestingly. They have used GPS and IMU sensors. Sorry, GPS and radar. The key finding of this the key finding of this paper is 79% of the task reduction with less than 50 millisecond latency. Yeah, the limitation of this paper is, however, the challenge remains right. These systems demand specialized hardware decision like standardization and privacy needs to be addressed. And let's move on to next paper, which is RF based B2B communication. RF is nothing but radio frequency by Zairang et al. Uh, Objective of this paper is implement low cost B2B alerts. The methodology they have proposed is RF communication using NRF modules. NRF module is a device. The hardware and software component is nothing but NRF24 L01, which has been integrated with Arduino Uno. The sensor they have used is proximity sensors. Uh, the key finding of this paper is uh, they have been achieved between 100 to 300-meter range without any cellular networks. The limitation of a paper is there is no AI integration in those limited range. Yeah. And moving on to next paper, which is vehicle to vehicle communication using LIFI technology. Publisher is IJRACET 2024 to develop a LI based V2V system, unlike radio based. This uses visible light for high speed data transmission. The methodology they have proposed is they are working prototype using LED and photodiodes and tested the transmission in real-time environment. The hardware and software they have used is LED and for transmission, photodiode for reception. The sensors they have used is IR sensors and LiFi components and lidars and cameras. And then the key finding of this paper is they have achieved over 100 megabits per pixel bandwidth, and it's immune to radio interface, which makes it ideal in crowded radio frequency environments. The limitation of this paper is, however, LAFA require a clean sight line of sights, and it's highly affected by sunlight, which limits its outdoor applications. And moving on to next paper, which is mesh networking implementation by the publisher by Avnet 2021. Objective of this paper is they have extended V2V range without any infrastructure. Methodology they have proposed is multi-hop mesh networking. The hardware and software which they have used is DSRC with cellular V2X modules, which is vehicles to everything with environments. The sensors they are used is GPS and IMU sensors. The key finding of this paper is they have achieved over 1 mile of visibility relays. The limitation of this paper is which requires critical vehicle densities. The next paper is V2V in smart traffic system by Kurt Wirth by Yoha Vinotoro at 2023. The objective of this paper by analyzing conjunction reduction methodology, which is theoretical modeling, like actually they haven't specified any hardware and software components. Also, they haven't specified any sensors they have been used, but the findings of this paper is 20 to 23% of conjunction reduction potential. The implementation is they haven't implemented anything technically. Next paper is yes SCAE V2 Export Technical Committee by Norla et al. At 2020. Objective of this paper is establish V2X message set security framework. Methodology they have been implemented is standard development and architecture review. Same like a smart traffic system. There is no hardware and software and sensors. They are used to keep any of this paper is provide a framework for secure interoperable V2X. The limitation of this paper is no empirical results and framework. Only framework. Only frameworks. The limitation of this paper is no empirical results, only frameworks. Let's move on to comparison table. If you see this comparison analysis, there are multiple using multiple technology we could achieve this V2V communications. One is DSRC, Uh, Another is cellular V2X, and by which we have seen in our research papers. Now both this LAF and RF. If you see the range of this, all the components, which DSRC have 300 meter over range. The latency is 50 milliseconds. Uh, because DSRC is mostly used like edge computing based, right? Unlike cellular, which is used through cellular devices through internet communications. And DSRC is privacy and security. There is no risk on privacy. The infrastructure, which is DSRC uses RFC dependent, which is a roadside unit. Cellular is which is range of 500 meter. Latency is about 100 milliseconds. Privacy is moderate. The infrastructure they use cellular towers. Part of uh, if you see radio frequency, which we use as a radio or NRF modules, range of 300 meter, which is equal to DSRs. Okay. And latency is variable, depends upon the surroundings and this module's response. And privacy is low. Infrastructure is there is none, which is we use as directly, right? And the LAFI based approach, the range is only 100 meters. Latency is less than 1 milliseconds. Privacy is highly risk, and infrastructure is they uses LEDs. Infrastructures they uses LEDs, and it's coming on to. So it's coming out to the key finding from the literature review. It summarizes key takeaways. DSRC and cellular V2X, which is vehicle to everything, are the backbone of V2V, but faces hurdles related to privacy and infrastructures. Um, the network limitation persists, especially in areas with poor coverages. Mesh networking offer a promising solution through the multi-hoop relays and ad hoc communications, extending operational range up to 1 mile. Implementation of the mesh can reduce infrastructure cost by 40%, and when combined with federated learning, offers a scalable privacy deserving model. So, so from these key findings, which brings me to propose a solution, which is federated mesh intelligence, which is FMI. How FMI works is, which uses decentralized mesh. Vehicles use DSRC to create peer-to-peer networks. Every 100 milliseconds, they transmit data packets containing speed, direction, and braking intent. The federated learning occurs in two stages. One is vehicle trained CNN or RNN locally on camera or lidar sensor data. Only the encrypted weights model updates are being transmitted. There is no sharing of raw data. You can find the weights over there. These are integrated by the neighbors using weighted average algorithms. And if you take a, let's assume some example scenario. Imagine a car overtaking another car in a fog environment. A car A nearly collide due to poor visibility. It learns from this event, fine-tune its model, and shares 0.5 MB update. Car B integrates this module, now reacts with 0.3 seconds faster in a similar conditions. So let's coming to the advantages of the FMI. Uh, there is we know that there is no GPS and data is being shared, so privacy is preserved. So it does not depends upon the cellular network, which works without cellular. I mean local mesh. And now let's go on to the conclusion of this V2V communications. So, in conclusion, V2V communication is not just a luxury; it's it's a necessity for the futures for safe transportations. So, my literature survey revealed a gap in current technologies, especially concerning privacy, scalability, and cost. FMI emerges as the strongest candidate to address these concerns holistically, and which also enables cross manufacturing collaboration in settings, the foundation of the standardized and vector neutral communication protocols. So, in conclusion, FMI solves 4 to 5 traditional V2V problems, like if you see privacy, latency, cost, and scalability. And this integration of V2V communication makes a significant step towards safer and more efficient transportation. And yeah, thank you.